70, what would it want to call it on the test? I mean, the problem, 70 and 90, 70 and 79. Hey, but there's a final exam. And that counts as 2 test grades. The question is, what does she need to get on her final exam? What does she need on her final exam to get a C in that class? So that's pretty much the question. All right, so this is how you sort of do it. So it's averages. Average is just you add how many there are and divide by how many, correct? So same idea. So this is how we're going to do it. You're going to take 62. You're going to add 84. You're going to add 78. And you're going to add, what's the last one? 90. But you have a final exam that's worth 2 test grades. So final exam, we don't know what it is. So we're going to make that 2x or whatever you want to call it. I'm going to call it x. Now, to find the average, I have to divide by how many test scores there were. So 1, 2, 3, 4, 5, 6. There are 6 test scores. They have to be between a 70 and 79 to get a C. So it can equal 70 and she has a C. It could equal 79. She also has a C. Then we just have to solve for x. I mean, it sounds like just solve for x, but we got to solve for x. Okay, so we are going to add up all these numbers on the top. So 70 is less than or equal to, I'm going to add them up real quick. I did it earlier. I got 414 plus 2x over 6 is less than or equal to 79. Okay, so now how do we solve for x? Well, I'm going to get rid of that 6. So I'm going to multiply every single thing by 6. Because then the 6 will go away and I'll be left with just the middle. So 414 plus 2x is less than or equal to, again, I did this earlier, 474 less than or equal to 420.
Is it now, 314 or 414?
414. I got 414. Is it 314? Did I add it wrong? I did it real fast earlier. Hold on. Oh, it is 314. Thank you. 314. 314. Okay, then we have to subtract 314, that's 3, from all the sides. So because we're going to try to get to x. So we have 2x is less than or equal to. So 420 minus 314 is 106. 474 minus 314 is 160. And now I'm going to divide everything by 2. All right, half of 106 is 53. And half of 160 is 80. So on her final exam, she has to get between 53 and 80 to get a C. And that's how you sort of do that problem. Thank you for fixing me, whoever that was. All right, so if you had trouble on that one, that was a tough one. I agree. Any questions on that one in particular? I'm hoping that helps you get through that problem. All right, anything else specifically from homework that you remember? You can always email me. I have a lot of people email me, whatever you got. I got somebody with a question, go ahead.
Yeah, I have one.
Go ahead.
Okay, I didn't know if it was me, sorry.
No, you're good.
So I don't remember exactly what number it was, but I think it was on the 2.5 homework. Okay. There was one, and So the problem was like X greater than 2 or X less than 6. And
Okay.
it's where you were like having to put in the I'm trying to think of the word for it, sorry, like where the coordinates overlap.
Oh,
You know what I'm talking about? When you graph it, like
think I do.
it's yeah, it's supposed to be where they overlap. And I was confused on this one because it said, so like whenever you do it as the coordinates, it would have been 2 and then to infinity and then the U thing for the or, and then negative infinity to 6. So the place where it would have overlapped, it would have been the 2 to the 6. But the answer to the problem was negative infinity to positive infinity.
Okay, I know why. Okay, I know why exactly. Okay, so here's 2 and here's 6. Okay, this is a special case, and I didn't even realize that was part of your homework. I would have taken it off, but it's a special case. So don't worry about it because you're not going to see it on your test or anything, but it would be something like this. So from 2 is open circle, whoops, and 6 is also an open circle, correct? All right, so 2 is greater than, and 6 is less than. And what happens is they overlap each other, and it winds up being negative infinity to infinity. Versus the ones we did before where they actually go together. Remember, the ones like that look like this. X is less than 2, which is less than 6. That's the one you're thinking about. This is a special case. So if I had this problem, 2 is less than X is less than 6, there's my 2, there's my 6, then I got that. It's everything in between. This is saying everything less than 6 and everything greater than 2. And what happens, they overlap and they become everything. But don't worry about that problem. That won't be on the test. Okay, that's a special, very,
Okay,
very,
thank
very,
you.
yeah, you're welcome. That's a very special case that comes up like never. So awesome. Great one. I didn't realize that was there either. Very good. Anything else for homework before we start?
I have a question.
Yeah,
So
for
when you're writing a solution set in a compound inequality, how do you know when to include the U, like the
Okay, perfect. Good question. Okay, so let's say I'll put over here in the corner. So let's say I look at 2 different cases. So let's say I have the one I just did, 2 to 6. It's the one I just did. And I have one that goes like this, 2 to 6. Okay, so this, the interval notation would be 2 to 6 with parentheses, everything in between. This one would be negative infinity to 2, union, because there's 2 parts, parentheses 6 to infinity. So it's when they are when is this? When you have the lines going like this and they're separated. When it's all one piece, you have one interval notation and no union. But if you have 2 pieces, you're going to put union in between. Does that help?
Yes, ma'am.
Okay, awesome. Awesome. Great questions. Anything else? Anything else? Okay. Okay, let's do our new stuff. Hey, today we're going to start out with functions, which is 3.2. Oh, before I even start the new stuff, did you guys all read what I sent in the announcements? I think you should have all got an email about the test. Make sure if you haven't read it that you are ready for the test on I forgot today's Wednesday. On Monday, test is Monday, right? Now we also have to learn a section or a section and a half on Monday. So I think you guys should probably like to do the test first and then come back and do the section later. So if you're somebody who finishes a test real quick, you can like take a little break and I'll tell you about when to come back. And then if you're someone who needs all the time, that's fine. Okay.
I did have a question. If I don't know if you guys can hear me, I'm not sure. Can you hear me?
Yeah, I
Oh,
hear
okay.
you.
Sorry, just 'cause my I
No,
don't
it's
know
all
what-
right. You're fine.
This was for the homework. It wasn't a problem per se, but it was like, you know, when it says to save, and I know that you told me that they don't kind of talk to each other, the student thing, and then the math lab. So
Yep.
if I hit save, I can go back to it because it's not due that day, right? Like if it's not due that day, I can still save and come back.
I just had something with somebody from another class. So she said, now I don't know your side that well. She said she didn't hit save. She hit submit or send or what's the other button you can hit? Save or what? What else can you do?
I think there is a submit. I hit save, but because I had
Okay.
to leave a while to get it done. But then
Right.
it said my grade went through with the ones I did do onto the student thing where the grades go. Like it says I got this percentage, but I wanted to go back to finish it, so I didn't know if it was going to let me. But I just wondered if you knew for.
Okay, so what I do know is that once you hit submit, it cannot be redone. For some reason, they don't give the teacher side a way to open it back up. So once you hit submit, I can't open it. Save should
No.
work fine.
What
Save should
she's
work
talking
fine.
about, I know what she's talking about. If
Okay,
you hit
tell me.
save, if you hit save, it will tell you your grade as of then. Whenever you go back in to finish it, it will change your grade though. You can go back in and finish it and your grade will change.
Perfect. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Whoever that was. Thank you. Thank you. Thank you. All right. So let's talk about a little bit about vocabulary about domain and range. Okay. So domain and range. I don't know if you've experienced domain and range yet, but domain are the set of all X values. They don't have to be X's, they can be any variable. So I'm going to put input values. So if it's A, it'd be a set of all A values or whatever you're putting into your equation. The range is a set of all Y values. But if you're not using Y, you want to think of it as the output values. Another big word, we have a lot of vocabulary, not a lot, we have a little bit of vocabulary to go on. So a relation. So you know how you have like a whole bunch of ordered pairs? That's called a relation. So a set of ordered pairs, meaning a set of points. I'll put that in parentheses, points is called a relation. So any set of points, it's just called a relation. And we're going to talk about a special relation in a little bit, but I want to show you how to do domain and range real quick. And there's also different ways to look at domain and range. I'm going to scoot it up a little bit. And we're going to do a couple examples. Determine the domain and range of these relations. That's how you're sort of kind of going to hear it said. They'll call them relations. Now that you know what relation is, it's a set of ordered pairs. So here's the first one I got. And there's your set notation. We talked about that last time with the set notation, but now it's just going to be ordered pairs. And that's how you write a set of ordered pairs. So all those ordered pairs are in a set, and we're going to talk about the domain and the range. Okay, I want to sort of put like a little note here. when you write your domain and range, the numbers should be in order from smallest to largest. And that's all the time. You should always put them in numerical order. Okay, I'll scoot down a little bit more. So let's talk about, there's my set. I want to look at the domain. And I want to look at what the range is. Now, the definition is called the set of input values. So we're going to have the set notation, and we're going to look at all our domain. So our domain are all the X values. So I'm going to sort of kind of label them a little bit. That's the domain, that's a domain, that's a domain, and that's a domain. They're my domains, all the X values. I'm going to put them in order from smallest to largest. So we start with -4, then we have 2, and then we have 4, and then we have 10. And that's my set of domain values. My range are my Y or my input values. I mean, output values, sorry. I'll make them little R's so you can see what they are. So then my domain, my range would be the set of all Y or output values. So I'm gonna put them in order 2, and I see -5, I see 3, and I see 9. Okay, so now that reminds me of something. I gotta go back. Oh, I can actually put it right here next to it. Okay, so values do not repeat. See how that had 2 9s? You only write it once. You don't need it twice. So input values or your X values or your range, you put them in order from least to greatest. Range are your output values or your Ys, you put it in order from least to greatest. And if anything repeats, you just write it once. And I'm watching you guys. I'm going to make a new page here in a minute, but I'm watching you to see who's writing, who's not. I see some people still writing, so I'll wait a minute. Okay, I'm going to add a new page. Hey, they don't always have to look like order pairs, even though they are order pairs, they're still input and output values. So sometimes they're a little different, like this. You can have a list. Let's say I have -1, 0, 1, and 2. I'll make that my input. And I'll make this my output. And I'm going to put -3, 1, 0. Okay, so what does that mean? So you're going to see something like this. I'm going to draw lines to each one. I'm going to show you what it means. -1 goes to 0. 0 goes to 1. 1 goes to -3, and 2 goes to 0. And I just made, believe it or not, ordered pairs. And I'll show you what I mean by that. So wherever the arrow goes, the input is your X, quote X, the output is your Y. So if I want to write this down as an order pair or a set of order pairs, -1, the line goes to 0, so that's the Y. So -1 is my X and 0 is my Y. My 0 in my input goes to 1, that's this Y, 0, 1. My 1 goes to -3, that's my order pair. And lastly, my order pair is 2 goes to 0. So it's another way to write ordered pairs in a very different manner. But we still do domain and range. It's still an input, it's still an output. Domain would be all my input values, -1, 0, 1, and 2. They're already in order, which is really nice. And my range would be my output values, which are also in order, -3, 1, 0. This is called mapping.
Wouldn't
If you
0
ever-
go before 1?
Oh, yeah. Yeah, thank you. I didn't put it in order, did I? Absolutely. It's called mapping. Sometimes it's called function mapping. We're going to talk about functions in a minute. But that's a different way to look at ordered pairs, a different way of looking at a relation, a different way of looking at input output. Okay, now I want to add functions. So functions is a big thing. Function is the thing. So functions. You're going to hear about functions probably the rest of the time you're in math. Okay, a function has is a special relationship, is a special relation. It is a relation, but it has a different quality to it than just a relation. It's just more than input output. It also has something else that's important. So to be a function, it's a relation where each input value has only one output. The way I remember it is this. X's can't repeat. So 1 can't go to 5 and 1 can't go to 10. It can only go to 1. Each input has only one output. 2 can't go to 0 and 2 can't go to 5. And only one output. Y's, well, this is not the definition, but Y values can repeat. The X values cannot repeat to be a function. Y's can repeat as many times as you want. The X's cannot repeat. Now, if I go back to the one we just did, I'm screening back up for a minute. If I look at my X values, did any of them repeat or any of them the same? No. So this happens to be a function. X values did not repeat, which means every X went to one Y. One X for one Y. Let me show you one that's not a function so you get an idea what a not a function is. I'm going to scroll back down. Okay, this is not a function. Not a function. Say I have an XY table. Another way you can show order pairs, XY table. And I have 1, 2, 2, 3, 4, 5, 1, 6. That is not a function because the 1 went to 2 and 1 also goes to 6. In other words, 1 repeats. That makes it not a function. Versus the same scenario, 1 goes to 2, 2 goes to 3, 4 goes to 5, 6 goes to 7. That is a function because all the x's do not repeat. And I want to show you one more. Let's do order pair. Okay, so the question is it a function or not? Question mark. All you have to look at are the x values. X, I have 1, 6, I have 1, 8, I have 1, 10, I have 1 and 12, 1, 12. That is a function. But notice I made the y's repeat. The y's, I have 2, 3 y's, I have 2, negative 2 y's. That's fine. Y's can repeat. To be a function, x cannot repeat. All right, stop there for a minute before I make a new page. Questions. We're going to look at functions in different ways. We'll look at graphs, and we're going to talk about when an equation is not a function. How do you tell when an equation is a function or not if you don't have the coordinates or you don't have the graph? We'll talk about that in a second too. Okay, I'm looking. Some people are still writing, so hold a second.
I wanted to ask while the people are writing, will we have time after class to discuss things that are not of course matter?
Yeah, that's fine. I stay on after class. If you ever need something after class, I'll stay on after class. That's fine. I'm fine with that.
Okay, thanks.
Okay, new page. If you ever need anything and you want to talk after class, feel free. I stay on until everyone leaves. So if you want to talk to me in private, everyone else can leave. We can talk, whatever. That's fine. You're good. Okay, so let's talk about what it looks like in an equation. Okay, function, equations. Equations that are functions, not functions. There is 2 things you need to look out for equations. I'll be writing that. I don't like it. Okay, so now let's talk about ones that are functions first. Actually, no, let's talk about what are not functions. The rest of them are functions. Equations that are not functions. That is not a function because y is squared. You can never have a y squared to be a function. X can be squared, y cannot be squared to be a function. I don't know, you probably don't even know this, but this is the equation of a circle. It looks like that. And we're going to talk about that in a minute in a graph, that's not a function. All right, if you ever have x equals some number, like 8, that is not a function as well. And for what we're learning now, 3x minus y equals 10, that's a function. X squared minus 2 equals 9 is a function. X squared plus 2x minus 3, that's a function. I guess I should put it equals 0, function. The square root of x equals 10, function. So these are the 2 things you gotta look out for to avoid. An x equal 2 and a y squared. And that's how you know it's a function, just by looking at it. Now, your book wants you to plug all these points in to see if it's a function. So your homework might ask you the same thing. So if you see a y squared or you see an x by itself equal to, that's not a function. Everything else is going to be a function. And to plug a point in, you just pick an x and find a y and you see if it works. And it will, unless it's a square and an x equals. So one thing too, also to remember, which I really didn't stress, but a relation is not necessarily a function. It has to be a special case, right? But all functions are relations. Okay, so now we looked at coordinates, how to find a function or not. We looked at ordered pairs. We looked at certain mapping. We looked at equations. Now let's look at graphs. How do you know if a graph is a function or not? I'm gonna make a new page. I'm just gonna take up a little bit of time, a little bit of space. I need a new page. Okay, so now let's look at graphs. Functions and not functions. Now, what's really interesting is that if you have a non-function equation, you can't enter on your computer, on your calculator. It won't go. It won't work. There's like no way to enter a non-function in your calculator. So if you try to put x equals 5 in your calculator, it's impossible. It won't let you do it. Hey, graphs. There's one thing that helps us with graphs. Oh, hold on, I got people entering. Hold on 1 second. Okay, so one thing about class, you've got to be here on time. I don't mean just people who are entering now. A lot of people enter late, and I know I was sort of stuck because I had a problem, but I do start right at 2. I really do. So be on time, because that just took me away from what I was talking about. So now I forgot what I was talking about because someone had to enter. So hold on. Vertical line test. Okay, there's one thing to tell when you have a function or not in a graph. It's called a vertical line test. And you really take a graph and you draw a vertical line. I'm going to tell you what it means. So on a graph, if you draw a vertical line anywhere on your graph, and you only touch your graph, I gotta say it, not you, and it only touches your graph, it only touches your graph once. You only pass your graph once. It's a function. And the other part of that is if it touches your graph or crosses your graph more than once, it's not a function. So if you draw a vertical line and anywhere on your graph and you only touch the graph once, it's a function. Why is that? Because it's saying X does not repeat. So I'll show you in a second. Just a little tiny graph. 2 points actually. If I do a vertical line and I do a vertical line, how many times do I touch the point? I touch 2 points, right? That's not a function. Not a function. And this is why it's not a function. So let's just say this is at 3, this is at 1, and this is at 2. These coordinates would be 3, 1, and 3, 2. And notice that my X values repeat, right? X values repeat. So it definitely is not a function. So the vertical line test is a visual way to see when the X values repeat, when it's not a function. So in order to be a function, your vertical line can only touch your graph once or cross the graph once. And that's it. Any more than that, not a function. And I have lots of graphs to do. I'm going to scoot down just a little bit. Okay, so let's look. The question is this a function or not a function? And this is for graphs. I'm just going to do just a generic graph. I'm not going to label anything, but I'm just going to show you what it means to be a graph, to be a function or not. So here I have this parabola. If I draw a vertical line anywhere, I'm only touching that graph at one point. I only cross that graph one point with every vertical line. So that is a function. Which also means the x values didn't repeat.
Would a parabola always be a function?
Yep, parabola is always a function. Yes, yep. It's a great question. Now you said that, let's talk about a line, because we're doing linear equations right now, right? If I have a line, is that a function? If I cross, remember how many times I draw a vertical line? I only cross that line once. It's definitely a function. But there is one line that is not a function. And let's say this is at 6. This equation of that line would be x is equal to 6. Remember way back a couple times ago, I said anything that has x equals is not a function, right? That's because it makes a vertical line. And if I do the vertical line test, I'm not going to touch the graph every single point. So a vertical line is never a function. So this is not a function, because all the x's repeat. This could be 6, 3, this could be 6, 2, this could be 6, 1, this could be 6, -5. The 6's repeat all the time, not a function. And that's why you want to be careful in an equation. X equals a number cannot be a function ever. Now, earlier we talked about the circle, and I think the equation I wrote was x squared plus y squared is equal to 8. I think that's what I wrote earlier. And I said that's not a function because we have a y squared. Let me make it nicer so you can see it. We had a y squared. Well, that makes a circle. So here's my graph. My graph is a circle. If I do the vertical line test, I could just do it once. I cross in 2 points. Now, you could draw it out here and touch 1 point. That's all right. Doesn't mean it's a function, because you can do a vertical line anywhere on your graph. As soon as you hit 2 points, you know it's not a function. And that's also why we talked about y can't be squared. It makes a circle. And a circle is not a function. So in summary, vertical line test is for graphs. And if you draw a vertical line anywhere, now you don't actually have to draw a vertical line. You can, in your mind, draw a vertical line. I'm just showing you vertical lines because this is our visual. But in your mind, you're going, wait, if I draw a vertical line, it's going to cross twice, or 3 times, it's not a function. If I do a vertical line and I can only cross the graph once, then it's a function. Hey, questions? I'm going to give you 2 to try here in a second. Any question on anything I just did? Okay, so guys, I'm not really checking chat. If you have a question, just hit the space bar and ask, because I'll hear you. It's touches my what once. All right, so the vertical line can only touch the graph once. It can't be more than once to be a function. Lines, except for x equals, are functions all the time. X equal, never a function. And if you y squared, it's not going to be a function. If you have x squared and y squared, x can be squared, x and y cannot be squared. Okay, so let's try on two graphs for you. And I just need to know, is it a function or not? So there's my two graphs. So think about what you were saying. I'm going to label this 1 and 2. Number 1,
Not a
not a
function.
function. Not a function. Very good. Thank you. Number 2,
Function.
function. And number 1, because either you draw it or you do it your mind, you're crossing that graph once. And I don't care where you do a vertical line, you're only going to touch it once. So no function. Function. All right, questions. I'm gonna turn a page. I'm gonna give you 1, 2, 3, 4. I made 6 things up, but either a function or not. It's not just graphs, it's graphs and input output. Okay, so I am going to add a new page and then I'm gonna write these down and then this is for you. So it's either function or no function. That's the question. Okay, so I'm going to draw these. 1. And as I do them, write them down. This is a function map. It doesn't have to be a square. It can be a circle. Write them down as you're doing them and then think about them. Did that one wrong. Before we get to start, it's a little tricky. Oh wait, not ready for that yet. And I'm just thinking for a minute. I had an idea in my head and then left me. So just keep going. Got it. Okay, and I'll be, they're the 6. I'm just gonna give you time to think about it. And we'll come back. Hmm. Good. Jet Li, perfect. You got 4 right. Good. Amber, the only one is number 4, which is a tricky one. And we'll talk about that in a second. Some people are sending me their answers. I'm sort of checking them out.
Are we supposed to send you the answer?
No, you don't have to. I'm
Oh,
gonna go. No, you're fine. You're fine. You're very fine. Just some people are like, "Ooh, I'm gonna send it the answer and see if I'm right." So you're good. You're good. You're good. Somebody is listed as Zoom user. I don't know who it is. Make sure I get your name before the end of class, or I won't know you're really here. Doesn't have your name on it for some reason.
That's me.
Who's me?
Angie, sorry. Angie Leon. I was having so much trouble logging on the whole entire time. I have absolutely no idea what I did because I was trying so hard to make it work. So honestly, when I saw ZU, I was like, I'm gonna go for it.
That's fine. That is fine. Okay, wait. Tell me your first name again. I'm gonna mark your apps here right now.
Angie Leon.
Got it.
Yeah. So
Got it.
yesterday I had a little bit of problems too, but it pretty quick from my actual account. And then all of a sudden today it was just like not wanting to work with me. So I don't know what I did, but I started so many accounts and it just went through.
That's fine. I just want to make sure I make you mark you here. Okay, so I'm stopped looking. Sorry. Here we go. Ready? Okay, so number 1, not function. Why? Because 1 goes to 3 and 5. All right, 1 goes to 5, 1 goes to 3. Can't have that. If you don't see it that way, take a minute and write down the coordinates. So I see 1 goes to 3, 1 goes to 5, and 2 goes to 4. And this right here is why it's on a function. All right, number 2, not a function. It doesn't pass the vertical line test. If you do a vertical line anywhere, well, not anywhere, but if you do a vertical line, you eventually will pass 2 points. 3, function. All right, there are no X values that repeat. Y repeats, doesn't matter. The X's are fine, 1 of each. Beautiful. All right, 4 was a tricky one. So remember, an open circle doesn't count. It's just saying it ends there, but doesn't count. It's almost like saying less than or greater than, but there's no equal to part, right? So when you do a vertical line and you go through an open circle and a closed circle, only the closed circle counts. So you're only passing once. So that is a function. And we didn't even talk about it, but I want to see what you guys could do. Beautiful. 5. I got a problem. Doesn't the 5 repeat? So that is not a function. And then the last one, I don't care wherever I draw these points, it's just a bunch of points. They're not lined up on top of each other. It is a function. So how we do? Yeah. All right, so we're about to do the harder one. This is the hard part. Finding domain and range from a graph. Now, unfortunately, we're online, not unfortunately, but I'm going to have to draw these pictures, so they're not going to be as beautiful